Hello, this is the next video in a playlist that I'm calling combinatorial results. So if you want to go into that playlist, you'll see this video and more. In this video, we're going to look at the probability of sorting cards into correct piles. And that'll make more sense as we go through the video. But part one here really stems from a Reddit post that I saw the other day. And then parts 2, 3, and 4 in a table are expansions of this original Reddit post. So here it's the probability of sorting black or a deck of cards into two piles, reds and blacks. Now, most people incorrectly think that it's 1/2 raised to the 52nd power. And so here's the reason that they incorrectly think that. So when you have a shuffled deck of cards, you can take the top one off, then you have to think to put it in the left pile or the right pile, and there's a 50-50 chance. Now, you take the next card, and you have to decide put it in the left pile or the right pile, and there's a 1/2 or 50% chance of that. And you go through all 52 cards, and so the probability has to be 1/2 to the 52nd power to sort these cards correctly, and that is not correct. So why is the sample space not 2 to the 52nd power? And it's this. So we have two piles. I'm going to call them a left and a right, or you can think of it as red and black or black and red. But if we just think of the left pile first, now if the sample space is 2 to the 52nd power, then the left pile could have anywhere between 0 and 52 cards in it, right? However, under this situation, we must have 26 cards in each pile, right? We know that. In order to sort this deck correctly, there has to be 26 cards in the left pile and 26 cards in the right pile. So at some point, if we're guessing left, right, and one of those piles reaches 26, then we know all the other cards have to go in the other pile. Otherwise, there's no chance of it being correct, 26 in each card. So we are restricting the sample space quite a bit, and it's actually more than quite a bit. It's a large amount. So here's the probability, the correct probability. It's the correct ways to have sorted piles over the total number of ways to sort a pile. Now the numerator is 2. I put 2 factorial, but it's the same number because you can have the reds correctly sorted on the left and the blacks on the right, or the blacks on the left and the reds on the right. So there's only 2 ways to have correctly sorted piles. But in the denominator, the total number of ways to have 26 cards in each pile is 52, choose 26. So that's a combinations calculation. And then times 20, and then once you choose the 26 cards, then there's only 26 cards left and they go into that next pile. And it's a product. And so the answer is 4.03 times 10 to the minus 15th. And that's an incredibly small number. And that's it. And if you calculate 1/2 to the 52nd power, this is a tremendously small number. And this is really small, but not as small as the previous one. So now let's go on to some expansions here. On part 2, let's just assume we have a generic deck with 2 end cards. And I put the 2 out front because the number of cards has to be divisible by 2 in order to sort them into 2 piles. And so the generic probability that you sort the cards correctly is 2 factorial divided by 2n choose n times n choose n. And notice that n equals 26 is a normal deck of cards, right? If n is 26, 2 times 26 is 52. And then we're back in case 1. Now, for case 3, I thought, what's the probability that we sort a deck correctly into 3 piles with 3 end cards? Now, there has to be 3 end cards because the number of cards has to be divisible by 3 in order to get 3 equal piles. Well, the probability of sorting the cards into 3 correct piles is 3 factorial. And it's 3 factorial because you have 3 piles and they're all correct, but the arrangements can be different. The middle, the first pile on the left, you have 3 piles and you choose one of them for the left. You have 2 piles left and you choose one for the middle, and then the last one is on the right. And the bottom is 3 in, choose in. That's the first pile on the left. 2 in, choose in. That's the middle pile. And of course, the right pile is in, choose in, which is 1. So this is the probability. Now, part 4 is correctly sorting the deck of cards into 4 piles with 4 in cards in the deck. Right? Has to be divisible by 4 in order to separate them correctly. And the probability is 4 factorial, because that's the number of ways you can mix those 4 piles up and still have correct piles. And the denominator is 4 in, choose in, 3 in, choose in, 2 in, choose in, and that's it. And notice that when n is 13, right? So 4 times 13 is 52. 13 cards in a suit. We're back into a normal deck. So if you take a normal deck of cards and try to sort it into 4 piles, where the 4 piles are the suits, the probability is 4.47 times 10 to the minus 28. And that's an incredibly small number. And you can kind of hear my cat in the background. She's like, who's he talking to? You know? And so she always comes in as usual. Now, but I got to thinking, okay, this is incredibly small. But what if I start taking cards away and then try to sort them into 4 equal piles of the suit? So, you know, how many cards do I have to reduce it to have the same probability as the original probability of taking 52 cards and sorting them into blacks and reds? And that's what this table represents. So it's the number of cards needed to be right around the probability of taking 52 cards and sorting them into reds and blacks. So if we look at pile number 4, so we're sorting the cards into the 4 suits: hearts, spades, diamonds, and clubs. If we take away 5 cards in each suit and then sort them, we're still a little bit less probability than the original 52 sorting into reds and blacks. So if we take 1 more card from each suit, then the probability of, so we have 28 cards total, then the probability of sorting these into the 4 correct piles is actually higher than the probability of sorting the 52 cards in the reds and blacks. And then I just went ahead and did it for the number, 3 to 8 piles. And the cut point is somewhere between these 2 cards. So so we'll just leave it at that. You can look at it on your own time. And that's all I have for this. The next video is going to be an R program that I use to calculate these probabilities exactly. And I also do a cool simulation that generates code as it runs. And so that's what the next video will be in. So I hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.